Hello and welcome to this Python tutorial. So in the previous tutorial we did the preprocessing phase, we imported the dataset, created our matrix of features X that is just composed of the levels column, the 10 position levels in the previous company of the employee we're about to hire, and the dependent variable vector Y, which is here, and that contains the 10 salaries associated to the 10 different levels of the matrix of features X. So okay. And then we didn't need to make any split of the data set into the training set and the test set because simply we don't have much information. And no need to apply feature scaling either because we're going to use the same library as we used for linear regression, which is a library that does the feature scaling itself to make more accurate predictions, and therefore no need to apply feature scaling here first. Okay, and now in this tutorial we're going to make two things. We're going to build a linear regression model, exactly like the ones we did in the previous sections, and also, of course, we're going to build a polynomial regression model and fit it to the dataset. So why creating these two models here? Well, it's simply to compare them. We're simply going to make this linear regression model as a reference to then be able to compare the results of polynomial regression to the results of this linear regression reference space. So let's build these two models and then let's see what happens. So we're going to build the linear regression model pretty quickly because that's exactly what we did in the previous sections. So as you remember, we need to import the linear regression class from the sklearn linear model library. So let's do this from sklearn.linear model. Import linear regression. Okay, so that's our class, and now we're going to create an object of this class, which will be the linear regressor object. Only this time we're not going to call it regressor like we did in the previous section, because simply we're going to make here two regressors. So we need to distinguish them, and therefore we're going to call the first regressor linreg, and the second one linreg2, because you know the second polynomial regressor will be based on a linear regressor on which we will add some polynomial terms. So this regressor here for polynomial regression will be called linreg2. But the first one here for simple linear regression is going to be called linreg. Okay, so that's our first linear regressor. And now you know what to do. We need to call the class, the linear regression class that we just imported. Here it is. Don't forget the parenthesis. No need to input any argument here, we're all good. And now, of course, we need to fit this simple linear regression object linreg to our dataset composed of not xtrain and ytrain this time, but x and y, because we didn't make any splitting of the dataset into the training set and the test set. Okay, so to fit this linreg object to x and y, we need, as usual, to use the fit method. So we add here dot, and then we pick the fit method here, and then in this fit method we need to input x and y as it's shown here, and therefore x, our matrix of features, comma, and y, our dependent variable vector. Okay, and now our simple linear regression model is ready to be created with only these three simple lines. So let's do this. I'm going to select this. Alright, press Command and Control plus Enter to execute. And here it is. Simple linear regression model well created. Okay, and now let's build the polynomial regression model. Okay, so to create this model, we are going to import a new class, which is simply a class that will give us the tools to include some polynomial terms into the linear regression equation. And this class is called actually polynomial features. Okay, so let's import this class and then let's see what happens. So this class is actually in the preprocessing library. So here we'll type from sklearn.preprocessing. Here it is, enter. Alright, so preprocessing is actually a library that we already used for feature scaling, but this time it will not be to import the standard scale class, but the polynomial features class. Okay, so speaking of that, let's import it. So import, and then polynomial features. And now, as usual, when we create a class, we create an object of this class. And this object, we're going to call it poly_reg. Okay, so what is this polyreg object going to be? this polyreg object is going to be a transformer tool that will transform our matrix of features X into a new matrix of features that we're going to call xpoly, which will be a new matrix of features containing not only this independent variable, x1, but also x1 squared, and if we want, x1 at the power of 3, x1 at the power of 4, up to x1 at the power of anything we want. So basically it will just transform x, composed of only one independent variable, into a new matrix xpoly composed of this independent variable and new independent variables, which will be this independent variable at the power of 2, of 3, of 4, of 5, etc. Okay, so that's what it will do, and so let's create it right now. So we're going to call this class polynomial features as usual. So paste it here, and now of course we add some parentheses as for any class. And now let's see what argument we can input here. So I'm going to press Command I to inspect the polynomial features class, and here I get all the info. So the only parameter that we are interested in is the first parameter, the degree here, because this parameter will specify the degree of the polynomial features in our future matrix of features xpoly. So to start, let's actually pick the default value, which is 2. So I'm going to input here degree equals 2. Okay, so that's the first step, create this polyreg object. And now what we need to do is to actually create this xpoly matrix that I've been talking to you about so much. So let's create it and let's find out what it looks like. So xpoly here, I'm calling it this way. And so of course now we're going to use our polyreg object that we just created. So polyreg here. And so, you know, as I told you, polyreg is a tool that will transform the matrix of features X into this matrix of features xpoly by adding the additional polynomial terms into the matrix X. And right now, since the degree equals 2, we're adding only one additional polynomial term. But since we're transforming X into xpoly, we're going to use here the fit transform method, because first of all, we need to fit our object to X and then transform X into xpoly. So that's the one we use, fit transform. And therefore, in fit transform here, we input, of course, X. So let's do it. I'm going to select these 3 lines here and press Command or Control plus Enter to execute. Here we go, perfectly created. Now let's go to Variable Explorer and let's have a look at xpoly. And I'm also going to open X to compare. Okay, so let's see what happens here. So first of all, we have the original column here, the original independent variable, that is the variable of the 10 position levels in the previous employee's company. And now in this new xpoly matrix here, we have 3 columns. So let's first notice that the position levels column here of X is actually the column in the middle, and that corresponds to x1, the independent variable. And then we notice that this second column here is the squared of this first column here. So that's actually the polynomial term. That is that, you know, we call this independent variable x1. Well, this variable is x1 squared, because as you can see, each value here is the squared of this value here. All right, so we get that. And now what is this first column here? Well, remember in the multiple linear regression homework, when we were implementing backward elimination, we had to manually add a column of 1s, you know, to include the constant b0 in our multiple linear regression equation. Well, here it's exactly the same. This polyreg tool object that we created automatically created this column of 1s here to include the constant b0 in the multiple linear regression equation. And so it automatically did that in case we need to use some libraries that need to have this column of 1s here included in our matrix of features. All right, and now we only have one thing to do left, is to actually include this fit into a multiple linear regression model. And to do this, we are going to create a new linear regression object that we're going to call linreg2. That's why I call the first linear regression object linreg, that was used to build a simple linear regression. And now we must create a new linear regression object to not make any confusion with the first one. And the purpose of this second linear regression object will be to include this fit that we made here with our polyreg object and our xpoly matrix of polynomial features into our linear regression model. So here let's create linreg2 equals linear regression, parenthesis. And now we need to fit this linear regression object to xpoly and y. So again, we're going to use the fit method here, and inside we're going to input xpoly and y. Alright, and now our polynomial model is created. So at first it can appear a little confusing, but basically when we take a step back, what we did is actually very simple and logical, because with these three lines here, we actually transformed our original matrix of features x into our new matrix of features xpoly containing the original independent variable position levels and its associated polynomial terms. And then once this new matrix of polynomial features xpoly was created, we created a new linear regression object, linreg2, that we fitted to this new matrix xpoly and our original dependent variable vector y. So that's exactly as if, you know, we were building a linear regression model, and in the first place we had this xpoly matrix here containing two independent variables, the position levels and the squared position levels. Okay, so now let's see what we need to execute. Here we executed the first three lines of this code section here, and so now we need to select the last lines to complete the rest. So press Command and Control plus Enter to execute. All good. And now our polynomial regression model is created and ready to reveal truth or bluff. So that's what we will be doing in the next tutorial, and I look forward to seeing you there. Until then, enjoy machine learning!